So we are still discussing what things or what factors are going to affect growth or size or lack of growth of a population. When you see the words density, and basically it's going to be broken down into these two categories. So a population is either going to be dependent on specific things in order to survive, or there's specific things within our population that need us in order to survive. Those two are considered density dependent. So we depend on specific things to survive, or there's things that depend on us to survive. Both fall under density dependent. Density independent will be factors that can affect the population both negatively and positively, but they have nothing to do with being dependent on a population. So give me ideas of what do you think one falls into the other. So what would be an example of something you depend on in order to survive and thrive? And water. What do we call water in science, in environmental science? A resource. So we depend on resources, yes? And if they're limited, then the population can be affected to grow. This is mine, right? Right here. What else? Competition. Predation. Even war. So organisms depend on each other for survival, but war is dependent on us in order to take place. So you see the difference there. What else? Disease or health. Okay, so health would fall under a resource, but disease falls under a type of density dependent factor that it needs us in order to thrive. So it's dependent on us. Give me some examples of density independent. So factors that can affect the population but have nothing to do with natural disasters. Good. A tornado, hurricane, even weather in itself can affect an entire population, but it's not dependent on it in any way. What else? Good. Deforestation or clearing of land. I mean, it would be a better word because that can also affect an entire population immediately. So we're going to take the time to look at and interpret graphs, okay? Curves, lines within a graph, different angles. One basically will always represent what the potential is of the population, okay? So growth of that population. I got to drag this down because for some reason I can't move this there. And then the other one is the resistance from the population that's going to affect the population growth either negatively or positively. Because there's things in the environment that can be available that can cause a population to grow. And then if you grow to a certain extent, the population can reach a limit and then the population will decline. So there's always going to be resistance from the environment or environmental conditions that will determine population's potential. And if we look at those two words, we're basically describing what's called the carrying capacity, okay? Where have you seen that word in your life? Carrying capacity. On an elevator. On an elevator, okay? In a restaurant, right? What does it mean? Good. The amount that can be sustained, we'll say, in environment or supported without ever having any problems. So, and forever. That is what carrying capacity is. It's always going to be referenced on a graph with the letter K. So when you see the letter K and it's pointing somewhere, that is the maximum amount of resources available to a population or the maximum amount of whatever they're referencing that can sustain a population within a given time indefinitely. Now, you also want to be able to see that when you see this J-shaped curve, you're referencing what happening to the population? Exponential growth. When you see an S-shaped curve, what do you think is happening to the population? Constant, stable, sustainable, a lot of people call it. That's the S shape. It's underneath the carrying capacity. So even though there was a time where the population was growing exponentially, it balanced out or stabilized somewhere below the carrying capacity so the population is not affected in any way. Remember when we covered fundamental niche and realized niche? And one really isn't real? Of course, they have to give you another term, intrinsic rate of increase. So if you see an R, it is the rate of growth without any factors influencing you negatively, which is not realistic. So it's very hard to understand why that it would even would exist. But I just want you to be familiar with that term, okay? All right, so I'm pointing to different parts of this graph. Who can describe any part? Like, knowing that the population is going like this right here, you know what's happening. How? Exponential. It's a J-shaped curve, so you know it's growing exponential. Now, up until here, it's fine. But after it passed this dotted line, the population took a turn. So what do you think this dotted line represents? Carrying capacity. So that's our K. This is the resources available to the population. Anything below is okay, but once you exceed, what do you think this point is up here? Right here. It is a peak, but what's a good definition for this peak? Because look what happens after you hit the peak. What happens? Decrease. So you've got a decrease. What? Max. What? This is the max that can be sustained. So if you're up here and you have too many people and not enough resources, what do you have? Overpopulation. Good. So you have too many people, not enough resources because we exceeded the carrying capacity. So the only thing left for the population is to decline. And then if I follow this dotted line here, what's this representing? So the population declined, and then here kept extinction or death. Good. But if this happens, what's happening right here? Recovery. And stable would be this. So I left stable out, even though I put it. It stabilizes because it's kind of going up and down. But stable would really be this. So let's point stable to here. This line, and recovery is definitely that curve going up. So you recovered here, you exceeded here, you declined here, stabilizing here, recovering, exceeding, right? Stable always wants to be below the carrying capacity. But or not, each one of these has a name. More importantly is, I know the name and I can apply it to a scenario, because it's always about that. So let's look at logistic growth, and each graph is colored according to the terms. So what's happening in logistic growth? Good job. You have exponential growth or rapid growth, and you should write the word exponential because I clearly drew a J-shaped curve and then I stabilized. So exponential and then stable. Good. Who could tell me about erupt? Well, there's no J there. So what's happening? Constant growth and then? And decline, like that's like death, right? Rapid decline. So can somebody give me an example of what would be a scenario that would describe logistic growth? An example of a scenario that describes logistic growth.
Like an invasive species.
I'm going to pause while you think. So Olivia said, any animal that's hunted during the season but has restrictions will have enough time for the population to regenerate, okay? And then, but still it's stabilized. So obviously they kept the population in a specific situation because of some environmental condition. How about erupt? Huh? You can say population had no obstacles. It's almost intrinsic rate of increase here. And then something happened to decline, like it could be some major environmental disaster or lack of resources. Now, why would you say lack of resources and not environmental disaster? Because it's above the carrying capacity, okay? So if you see this line and you see a K and the population was able to go up, but then it dropped, you know they lost resources, okay? So instead of talking about natural disaster, if I take this line away, then maybe. But if the line is there, it's telling you that we're talking about resources and they're a factor to be involved. All right, what's cyclic boom bust? Everybody loves that word. Up, down, up, down. So yes, boom, decline, right? What's happening there? Yes. What's happening to the population there? Like I want words that describe. What's happening here? We're growing. Then what happens here? Overpopulation, we lost resources. And then what happened here? Decline, decline. So what happened? Why is there recovery? Earth had enough time to replenish resources. So we must be referencing some kind of renewable resource that was able to replenish, okay? All right, tell me about stable. Why is it stable? Is it going up, down, up, down? There's no dramatic. It's right within the carrying capacity. So yes, there's a slight growth and a slight decline, but we consider it stable because it's right within the carrying capacity. And then irregular, no explanation whatsoever. Here, if you wanted to talk about an environmental condition like a natural disaster or war, this peak would describe it. Because there's nothing showing you that the resources were limited here, but something happened drastically to the population. So here would be that example you were referencing, like an environmental condition.